Hello guys, welcome to my test yourself video that is dedicated for the practical part of the Embryology Colloquium 1. This is a bastardization of a demo colloq. Hopefully it makes sense, hopefully it's going to help a lot of you guys. We can start with giving examples and kind of explaining how things are going to go. Each test is going to act as your attempts. Now, what do I mean by that? Well, we're going to have 4 tests in total. That's just how far I'm going to go. And that means that you're going to be able to do this 4 times. So test yourself 4 times with 10 different structures for each test. Hopefully that makes sense. So before each and every test, I'm going to have to ask you to write a list of the numbers between 1 and 10. So that we can easily just write down the slide name and the structure name of each number. For example, for the first test, we have the numbers 1.1 through 1.10. And for the second test, that would be 2.1 through 2.10. Hopefully that makes sense. There's going to be 1 minute dedicated for each structure, so hopefully you don't pause because that's just how me trying to make it as authentic as possible, since during the practical part of your colloquium you actually only get 10 minutes to fully finish the colloquium, so 1 minute per structure just makes more sense. Now this is going to be an example of how this works. So we're going to have 1 page dedicated for the low magnification. For example, if this was the first test and the first structure, 1 page for the low magnification and 1 page for the high magnification. Both are going to be shown to you within the span of a minute. Now, since we can't really show you the direction of the camera, because again, these are images, I'm going to just write an arrow of where we're going. So in this case, we're going towards the bottom right and showing you these structures. And then more zoomed in, that would be the actual structure that I'm interested in. So in this case, since I'm asking you to write both slide name and structure name, you have to write in the slide name, which would be embryo in sagittal section, and then you can also write in the age, and then also the structure name that I'm interested in, which is the metanephros, all within the same number, which is 1.1 in this case. First test, first structure. I think that makes sense. Is there anything? Oh yeah, some professors ask you to only write in the structure name, so in this case only the metanephros, not the embryo and sagittal cut, but other professors do ask you to write both. So in order to be fair to everyone, we're going to ask you to do both of them, but please ask your professors before your actual colloquiums to make sure that you're doing what they actually ask you to do. One final thing before we start. After each test, I'm going to go through all 10 structures and answers, and I'm going to show you what to look out for. I'm going to show you what the professor are trying to show you and what picture they're trying to paint to you in order for you to gain all the points. Also, I'm going to tell you where you might lose points, what other structures are important for that specific image as well, and maybe some structures we haven't covered in other tests. So hopefully that will make sense. All right, without any further ado, let's start the first test. So this is 1.1, and this is the slide we're looking at. Now in further magnification, we have this area. And I would like you to write down the structure name of this thing. So both the slide name and the structure name, please. Okay, next number, 1.2. And this is what we're looking at. I'm gonna further zoom into this area where we're gonna see this. Now the structure name I would like you to write is for this thing. Again, this is where we zoomed in, and this is the structure I would like you to write. So slide name and structure name, please. Okay. Next, 1.3, this is the entire slide. Hopefully that makes sense. And we're going to focus on this structure, so zooming in, this is what it looks like. So this entire structure, please write down the name and write down the name of the slide as well. Lower magnification, this is the structure we're looking at. But in higher, this is what it looks like. Okay, carrying on to the next. This is the slide we're looking at. This is for 1.4. We're zooming in and we're seeing this. I would like you guys to write down the name for this structure. Okay, next. 1.5, and this is the area we're looking at. A little bit low quality, but hopefully it makes sense. I'm zooming into this specific area, or no, sorry, to this area. So something like this, right? We see these structures. I'd like you to write down the structure name for these. So slide and structure name. This is where we zoomed in. So again, these. The next structure, we're within the same slide. And like instead we are zooming into this area now, and we're seeing these. I'd like you to write down the name of this. So again, same slide, we're zooming into this area. I'd like you to write down the name of this. Okay, moving on. Now these are a specific slide, very big, right? We're starting off here and we're moving upwards or downwards. We're moving in this direction. So we see this is the next image. Further upwards, this. And further up would be this. Now in higher magnification, that looks something like this. I'd like you to write down the name of this structure and the slide name as well. Okay. Next slide looks something like this. It's within the same slide actually. We're just moving further down, so that was the area we were at. And now further to the left, we see this. We're zooming into this area. We see something like this. Please write down the structure name of this area. And the slide name will remain the same as the one previous, unless you want to change it. So again, this area. Same slide as 1.7, we're just now on 1.8. Moving on to the next, this is the slide we're looking at. We're on 1.9 right now. Okay, now zooming in. We see this. I'm gonna ask you guys to write down the structure name for this structure. So slide name and structure name, please. Okay, moving on, we're in the same slide. So the slide name can remain the same for 1.9 as it is for 1.10, unless you changed your mind. And then zooming in, we see this area again. But now we're asking for this structure. So please write down the structure name for that and review your answers if you find time to do so. Okay, that was the end of the very first test. Now we're going to go through the answers, and then we're going to follow through with the second test. Now we're going to go through all of the answers first quickly, and then I'll explain why the answers are the way they are and what to look out for during your time taking the practical colloq, and hopefully signs that would help you gain more points. So 1.1, the slide name was human uterus in proliferation phase, and then the structure name being the uterine glands or gland. Slide name placenta, specifically maternal. You could also just write maternal placenta. And then the structure being hormonal active cell of peripheral trophoblasts. It's not enough to just write HACPT. Slide name for this was the umbilical cord, and then the structure name was the remnant of allantois. Next one was the prostate, and then the structure name was the smooth muscle cell. 1.5 was developing limb, the structure name being skeletal immature striated skeletal muscle fibers. There we go, and then here it's the same, it's developing limb, and then the structure name being chondrocyte or hypertrophic chondrocyte 2. 1.7 is embryo and sagittal section. You have to add in age if the professor asks you to. However, that's something only the professor can discern, in my opinion. And then 1.7 is the metanephros, the structure. 1.8 is the same as 1.7, slide name, and the structure name being the developing vertebral column. 1.9 is the germ layer. Structure name is ductus mesonephriticus. Same slide for the next point, and the structure name here is the somatopleura, since the slide was upside down. Now we're going to go through all of them and explaining them further. Hopefully that will make more sense. So for this first slide, it was a little bit more zoomed in, since this amount of zooming out I don't think is possible for the microscope. However, what I do want you guys to notice, number one, is that it is the human uterus. And for that, I have been telling you guys that you're looking for this division of the myometrium, which is filled with all of these muscle cells, and the endometrium filled with all of these glands. Now that division is highly important, and it's what characterizes the human uterus. The second part of the slide name is the proliferation phase. Now you might have looked at these glands and assumed it was the secretory phase. However, like I said in my video, we're mainly looking at the glands towards the top, so the stratum functionale part glands, right? And since those are circular and very condensed, then we know that we're in the proliferation phase. If you don't write in proliferation phase, you're not going to gain all of the points. Okay. And for the structure name, obviously, this is the division between the myometrium and the endometrium, then all of these glands that have a thicker walls, or all of these openings, are glands. And then those that have thinner walls, or walls that you can barely see, are blood vessels with all of these blood cells in them. 1.2 is the placenta maternal. I wanted you guys to look at this area specifically, not really this. Well, this helps you see that it is the placenta because of all the tertiary villi compared to this decidua basalis area for the maternal placenta. However, what I wanted you guys to see is that it was maternal and not fetal, because again, if you only write placenta, you won't gain all the points. Now, if we look at the area here, we can see that there's no characteristic simple columnar amniotic epithelium like we see with the fetal placenta. We can only see this like harsh cutout, as if it has been, cut off with a scissors. Another very big signifier that we're in the maternal area, not the fetal, is the texture of this pink area, or the decidua basalis. We can see that there are larger cells and there are smaller cells, and then there are larger areas clumped together with cells like these, and then more scattered areas like so. So this is very characteristic of the maternal placenta. Then when we zoom in, we zoomed into this area, and yes, I do know that it is a little bit elongated, but it proves my point. You can see these cells being a lot larger than, for example, this cell, and that is very characteristic of the maternal decidua basalis and not the fetal extra embryonic mesenchyme. So knowing that you see all of these different sized cells, hopefully you'll get that those are the hormonal active cell of peripheral trophoblasts. If you only wrote HACPT cell, I doubt you'll gain any points for that. Next up is the umbilical cord. Hopefully here you can see that there are large blood vessels. Here's the edge of another one, surrounded by all of this texture known as the Wharton's jelly, and then this border known as a simple columnar amniotic epithelium. And then we have this thing in the center, which might look like a blood vessel, but if we zoom in, which the professor will do, you'll actually see that these cells are lined up together and have a clear cytoplasm, almost appearing cuboidal in shape. You can see them here, like these teeth-shaped cells, right? And if we know that these cells are not flat and elongated like the wall of a blood vessel with endothelial cells like so, instead they are shaped cuboidally like this with clear cytoplasms, Then we know for sure that this is a gland and not a blood vessel, right? And since we can see these cuboidally shaped cells here with the nuclei in the center, we can confidently say that this is a gland. And the only gland we really have in the umbilical cord is the remnant of allantois. Next up is the prostate. How do we know that this is the prostate? Well, it's very unique in the fact that all of these are glands and they're very scattered about. We don't really have a slide that looks like this with the glands scattered in different shapes. Maybe the human uterus, but then there's always like this divide between the myometrium and the endometrium. Also, the human uterus has very characteristic glands or characteristically shaped glands. These are very chaotic. Zooming in, you can actually see that these are glands. So you can see the cuboidal shape of them, as you see here, with the nuclei in the middle. So we know confidently that these are glands, not blood vessels. However, they might ask you about the blood vessel still when looking at the prostate to kind of fool you. Something like this would be a blood vessel because of the walls being a lot thinner. And then all of these cells, even though they look funny, they are smooth muscle cells. We have the developing limb here. Now, you might also write in like embryo and sagittal cut. I don't think it would be completely wrong, but if we only see the bone, we don't see any other organs that are characteristic for the embryo and sagittal cut, then it's enough to write developing limb. And you don't really have to write what kind of limb this is. I believe this is a leg, but it's all up to the professor. I think this is enough, or that's what our professor at least said for the slide name. Now for the structure, like I said, if we zoom in close to the developing bone area, what do we have close to bone? Well, we have skeletal muscle fibers close to bone, hence the name skeletal, right? And if we see these striations here, we know for sure that we're in muscle territory. So when we zoom in, it might appear a lot odder than when we zoom out, but this is just to show you that how it looks, how different it looks zoomed in and zoomed out. So here we see all of these striations, and if they ask you about a bunch of these, that would be fibers, plural. If they ask you only about one of these, then only fiber is enough. Or you can also add in fiber bundle here instead of the S. Actually, that would be more correct, I would say. Next up, same slide, but we do have these chondrocytes within the bone. I believe hypertrophic chondrocytes are enough because these do seem very hypertrophic to me. And that is a structure that you've learned from Colloquium 2 in histology, which they might bring back just to test you on that. Next up is the slide name here, and this would be the embryo and sagittal section. Some professors ask you to add the age. Personally, I don't think you can discern the specific age just from these slides that we've received. I could be wrong on that, ask your professor, but according to our professor, they said, no, you really can't. So therefore, the age wasn't really required for us in this area, in this specific slide. But for us, it was enough to just write that. And then for the structure, they asked you about the metanephros. However, or I asked you. However, in this case, we can see here that for our professors, they try to show you the overall view of the slide before getting into the structure. So here we can see the rib cage very clearly. So if we can see the rib, we know that we're in the thoracical area right here. Now carrying on down the embryo, this would be the lung. We can continue seeing the rib here. Then here, this is where the rib would end. So this is the border between the thoracical area and the abdominal area. So once we get here, we can actually get into the abdominal organs that we went through, and there are four. There's the developing gonad, there's the mesonephros, the metanephros, and the developing adrenal gland. And you know that you're in the abdominal area as soon as you see that end of the rib cage, and that the rib cage doesn't carry on here, then you immediately can assume that it is the abdominal area. So if you understood that from the ribs, you can hopefully get to figuring out that there are only really 4 organs we're looking at here. And like I said, this would be the metanephros then. Same thing here, only instead of being within the abdominal area, we're kind of going towards the back of the embryo. We're seeing all of these developing vertebra and vertebral columns. And that's what we have here, just lighter. This is more of a official microscopy picture, and this is more of an edited version. Okay, this is an interesting structure. In the variation I used, I didn't add in that arrow, right? And here the arrow is visible. That's because I didn't want you guys to see that it was actually an upside down slide. So in this case, the endoderm would be this line, while the ectoderm would be this line. And the somatopleura would be up here, while the somatopleura would be down here, and the splanchnopleuра would be up here. And how do you discern that this is upside down? You look at the notochord. So this would be the notochord. Notochord is usually at the bottom. So if you understand that, you will immediately know that, okay, this is an upside down slide. So whatever structures I assumed were up and down are now the opposite, right? So carrying on. Here we have this kind of opening area, and since we have a little hole in the middle, we know that it is the ductus mesonephricis, not the nephrotome, and it sits above the intermediate mesoderm right here, with the lateral mesoderm being here and the somite or the paraxial mesoderm right there. Next up, same slide. But here I try to see if you can actually name this area being the somatopleura, even though it is at the bottom, since this slide is upside down. Again, this is something that might appear in your colloquium, an upside down slide. So please look at the signs to see if something is upside down or not. Okay, we can get into the second test. And now we're going to get into the second test. Please write down a list of the numbers between 1 and 10. Write down the slide name and the structure name for each number. So let's start. This is the first slide you'll see. Then zooming in, I'm going to see something like this. My question is, and I'll be using this pointer because it simulates what you're going to get in the colloquium from the professor as well. Question is, what is this called? Next slide, see something like this. Now zooming in, I'm going to ask you about this structure. So please write in structure and slide name. Okay, next slide. 2.3. This is the slide we're looking at. Now we go a little bit further down and we're zooming in and we see something like this. And I'm going to ask you guys about this structure in particular. So slide name and structure name, please. Let me make sure I'm muting my phone. There we go. Okay, next structure or next slide. We see something like this. Okay, zooming in. I'm gonna ask you about this structure. During the colloquium, you can ask the professor to show you a similar structure in the same slide. If you feel unsure, it would be this as well. Okay, next structure looks something like this. So please take a gander. Okay, zooming in, we see something like this. Now for structure 2.5, don't forget to write the slide name. I'm asking you about this specific structure as well. So this area. Okay. Next slide looks something like this. Zooming in, we see something like this. Now please, for the structure name, write down this structure. What is this called? Okay, next slide. We have one of these larger ones. And in this specific slide, we're going towards the bottom right. So carrying on, we see this. Then carrying on towards the bottom right, we see something like this. Now we go a little bit towards the top, and we see this. Now, zoomed in, we see this area. Please write me the structure name of this. Don't forget the slide name as well. For the next slide, we're doing the same thing. So this is the exact same as 2.7. So we're within the same area and within the same high magnification slide. So I'm gonna ask you instead about this. Please write me the name of these. Sorry for the seagulls in the back. This area. Okay. Next slide, we're within the same slide. So again, you can write down the same slide name. This was the area we were looking at. Now we're going a little bit towards the top, like so. And then further up, a little bit like this, we see this area. Now we're honing in on this area, and we're seeing something like this, zoomed in. Please write down the name of this structure. The final slide is a new one. Looks something like this. Then once zoomed in, we see this. Please write down the name of this. Professor might only show you this, like so. But I'm being a little bit nice. Okay. That was all for the second test. Now we're going to go through the answers real quick and then go a little bit more deeply. Now for the answers, we have that first structure, and the slide name was the developing heart, 6 to 7 weeks. You have to write down if it's 6 to 7 weeks or 10 to 11, and I'll explain how you can see that in this slide further down after we go through all of the answers real quick. 2.1 was the myocardium, or the developing myocardium rather. 2.2 is the human sperm. We're gonna explain that as well. And then the structure was the urethral epithelial cell. 2.3 is the human uterus in secretory phase. And then in higher magnification, the area we were looking at was the simple columnar epithelium. Further down, the slide name of this slide is the embryo folding, and the structure we were looking at was the dermatomyotome. 2.5 was fetal placenta old, and the structure that we were looking at was that, and that was the simple columnar amniotic epithelium. 2.6 was the developing vertebral column, and the structure name was the primary ossification center. 2.7 slide name embryo and sagittal section, and then you have to add an age if the professor asks you to, and then the structure was the developing adrenal gland. Here the slide name was the same, and the structure was the developing cortex. 2.9 embryo and sagittal section again, and then the structure was the immature striated skeletal muscle fiber, so not the fiber bundle here. 2.10 was the new placenta. You don't really see if it's the fetal or the maternal here. And then the structure name was the syncytial trophoblasts. If you want to add in an S there as well, that would be good. Okay, going through all of them and what they mean and how to see them. So number 1, the age of this slide being 6 to 7. Now, like I said before, there are 2 signifiers of a heart's age. Number 1 is if it fits in the scope of the entire microscope. So in our case, I believe we don't have these circular microscopes for the practical part of the colloquium. They cover the whole screen, but you will still see the entire heart within that screen, right? If it was a 10 to 11 week old heart, which is the only other alternative other than 6 to 7, then we would only see a section of the heart. But in this case, we can actually see the entire heart because it's so tiny. And then another signifier is the pericardium, which is like a shawl-like structure that flows all around the heart, which we can only see in the 10 to 11-week-old heart. We can't see it in the 6 to 7-week-old heart. And the structure is the myocardium, which is just like a little section of tissue within the heart. And how do you see that this is the heart? Hopefully you can just see the characteristic shape of the heart with the trichoconal region. And the ventricles and atriums right there, chambers. Next up, this chaotic slide, like I said before in my video covering in class 1, very chaotic slides like this that appears as if it's just like a cloud of absolutely nothing is very common for human sperm, real human sperm slides. So you can't really see the characteristic shape of the sperm cells or the spermatozoa. And therefore, if you see anything that looks like this, very vague, 9 out of 10 times it's the human sperm. Especially if we see other types of cells, which we did here. The urethral epithelial cell is a large cell, and I think this is the nucleus, or this, not sure, but you won't see this largest cytoplasm. It kind of looks like a tick, right? Large cytoplasm, small body or nucleus. And that would be urethral epithelial cell, a very large balloon-like structure compared to everything else. Here, the human uterus, like we said before, there is a clear line between the myometrium filled with all of these muscle cells and the endometrium filled with the glands. So that's how we know we're in the human uterus. The next up is the phase of the human uterus. We know this is the secretory phase because we look at the top of the endometrium, the area of the stratum functionale. We see that these glands are very elongated and not rounded, right? And directed towards the lumen of the uterus. And that's how we know we're in the secretory phase. In high magnification, we're looking at this area. So this would be the lumen, or the outside, right? This white area, this right here. And the thing lining the uterus, like so, is what we see here, more zoomed in. This would be the simple columnar epithelium. A rather, like the name suggests, simple structure, but something that they might ask of you in the colloquium anyways, since it's such a simple structure, like a blood vessel. Next up is the embryo folding. How do we see that it is the embryo folding and not the germ layer? First of all, germ layer would be a lot flatter, looking something like this with the neural tube in the middle, right? But the embryo folding looks more like a three-headed clover, like so, right? Or like an upside down Mickey Mouse with ears. And that's how we know we're in the embryonic folding. Zoomed in, we see this area. You can see kind of it here, like a warm shape. Warm shape that is directed towards the outward area. So that would be the dermatomyotome. The sclerotome would be this area instead. So this is dermatomyotome and this is the sclerotome. Other things they could have asked you here, neural tube, but it is very, very easy. Same with the neural canal, same with the notochord. In this case, we see that the notochord is towards the bottom of the neural tube, so we know that this is not an upside down structure. Also, we can see it on the arrow, right? Okay, next up, the fetal placenta. We can see also here that it is old, a little bit harder to distinguish, but I think that the fact that it is the fetal placenta is more important. Now zoomed in, we're zooming into this larger area here. So here we have these tertiary villi. Here they can also ask you about the Langhans fibrinoid and the Rohrs fibrinoid, also the maternal blood they can ask you about. They can also ask you about the extraembryonic mesenchyme or extraembryonic mesoderm also is what it's called, or the mesenchymocytes in the middle. But in this case, it would be the simple columnar amniotic epithelium, just so that I'm not making a mistake. And that is also very characteristic of the fetal side. So if you, for example, accidentally wrote maternal here, they show you this specifically, and you figure out that it is the simple columnar amniotic epithelium, and that you can only see that in the fetal side, then you write it immediately. Also, yeah, how is that the fetal side? Well, number one, the texture of the pink area looks a lot more even when we zoom in, very even in structure. Not a lot of cells are very differently shaped or bunched together. And then, more importantly, we can see this simple columnar amniotic epithelium bordering, and this is what it looks like zoomed in. Here we have the developing vertebral column. Hopefully that makes sense in this slide, but if you want me to explain it to you, we have the bone development, and then in between the bone we have the developing intervertebral disc, and then another vertebra, and then another intervertebral disc. So it's kind of like a brick wall, but just with one line of bricks, right? And we have several different structures within the developing vertebral column. Also remember to write in developing, or else you'll lose points. If you only write in vertebral column, you won't gain all of the points. In the middle, we have the primary ossification center, which is always in the middle of all of these vertebral columns. Sometimes you can't really see them, like here. And they are lined by these hypertrophic chondrocytes. And then all of this dark purple area is the, I think it's called the extracellular matrix, but don't quote me on that. But yeah, primary ossification center. Next up, like I said, when we have the embryo and sagittal section, we'll see sections of it, obviously. But in this case, trying to point out the lung and the ribs, and then following the ribs we see the end of the rib cage, and that's where the abdominal area starts. So here, this would be the end of the rib cage, abdominal area here, thoracical area here. So only abdominal organs here, only thoracical organs here. So in this case, abdominal organs, we can only have 4, and in our case we can mainly only see 2 of them. So that would be the metanephros, and this would be the developing adrenal gland, since it kind of looks like a balloon or the top of a mushroom. Yeah, it's right next to the metanephros. Very characteristic of the developing adrenal gland. The gonad would have more like vein-like structures within, and it wouldn't be directly next to the metanephros. And the mesonephros would not look like this at all. So this is the same slides further down. This area is the developing cortex. Even though it is the metanephros, it's the developing cortex. I think that if you write in metanephros, you'll gain some points, but not all. And then the lighter area in the middle is called the developing medulla, which is also something they might ask you instead of the cortex. And again, you have to write in developing, or else you won't gain all the points. Next up, this slide in particular, same as always, only we're going upwards. And like I said, if we're within bone-like structures and we're looking around the bone in like weird textured area that kind of looks like it's striated like this, right, with longitudinal cuts, and we're zooming in and we see something like this, very characteristic of immature striated skeletal muscle fibers. Again, it's right next to bone, and in our case for the colloquium, they might actually show it to you in this type of slide with the embryo in sagittal section. Close to bone, very ladder-like, I don't know how else to explain it, like hair-like in structure. Zooming in looks nothing like it looks zooming out, right? And they show you only one, that would be the singular fiber. If they show you several, like here, you would add in a bundle next to this. Okay, and then the final one, 2.10. In this case, we don't see if it is the maternal or the fetal side. We don't see either of the sides, we only see the middle. But the important part is that you see that it is new placenta and not old placenta, since we can kind of see the 2 borders here, but we can especially see it when zoomed in. So if you can only see it when zoomed in, you can always go back and rewrite the slide name, right? So here we can see the 2 borders of these tertiary villi, and they're very characteristic of new placenta. Again, new placenta looks a lot more lighter, but only when you compare it to old placenta, and it has, more importantly, these two borders. The darker cells lining outside are the syncytiotrophoblasts, and then the lighter cells lining the inward section is the cytotrophoblasts. For old placenta, you don't have these two layers. You barely have the cytotrophoblasts. Barely. That's why they're always called the cytotrophoblast remnants. Okay, now we're getting into the third test. Remember to write down a list of the numbers between 1 through 10 before we start. Okay, starting with the first slide, looking something like this. And then zooming in, we'll see this structure right here. My question is, what is this structure called? Okay, next structure or slide, we're seeing something looking like this. We're not gonna go around the slide too much. It might appear harsh, but hopefully it could be or act as a challenge to you guys to figure out what this is. Yeah, there's no high magnification, and the structure I'm looking for is this area. So what would this be called? Again, a very challenging slide because you have to write down the slide name and this structure. And we're not really zooming in or zooming out too much. Doesn't really tell that much, but hopefully you guys get it. Okay, next slide looks something like this. Directly. We're not going to go through sections of the slide either. Instead, we're zooming in immediately. My question is, what is this structure called? Another fairly odd structure. Third attempt, I tried to make it a little bit harder for you guys, but hopefully it makes sense. Zooming out, it looks something like this again. Zooming in, this structure right here. Okay, next slide looks something like this. Let's keep it like this for a while. Again, this is going to be a little more bit more challenging of a structure or a slide. Zooming in, we see this area. What would this structure be called? Okay, next slide looks like this. Zooming in, we're looking at this area. Now please tell me what this structure is called. Okay. Next slide. We're in the same slide. All right. Zooming in. And the question here is, what is this called? Okay, let's go to the next slide. And this is the area that we're looking at for 3.7. So please write down the slide name. Okay, zooming in, we see this. And my question is, what is this called? Okay, next slide. We're in the same slide. All right, zooming in, same image, but in this case, I'm asking, what is this called? Okay, gonna end it a little bit earlier. Carrying on to this slide. Now take a look. You can also write down the slide name. All right, there's not going to be any high magnification here because of limited resources. But in this case, I'm asking, what is this structure called? So slide and structure name, please. Okay. Final slide for the third attempt looks something like this. So we zoom in, we go further to the right, we see this. Then I think further down, yes, further down we see this. Something like that. So again, if we go upwards, it looks like this. If we go to the left, it looks like this. Don't want to zoom out because that might give the whole picture. But hopefully this will be enough for you guys to figure out what kind of slide it is. Now zooming in, We're looking at this general area, and we've zoomed into here. My question is, what is this structure called? So slide name and the structure name. This one was a little bit trickier, I'd agree, but it might appear in the colloquium nonetheless. Okay, tricky attempt, but it is, I think, the most difficult of the four. We're going to go through the answers real quick, explain them, and then finally do the fourth attempt. We're going through all of the answers for the third test real quick. So the slide name for this was ovary. You could also write cat ovary. I believe that would be accepted as well, or maybe even better. In high magnification, the area we were looking at was the columnar cell ring. 3.2, there was no high magnification, so you would write slide name and structure name within the same image. Slide name was the maternal placenta, old. You can kind of see that it is old, but we'll get to that in a second when we go through all of the structures one by one. The structure was the decidua basalis. Why did that disappear all of a sudden? All right. Here we have the slide name, which was the embryo and sagittal section, and then we have to add in the age as well. For 3.3, the structure was the dorsal aorta. You can also see it here. 3.4, human uterus and secretory stage, and the structure was a blood vessel, non-specific. You can write spiral artery as well, could also make sense. I would say I would give you the points if I was the professor. 3.5, slide name the germ layer. And then in high magnification, we had the nucleated erythroblast. 3.6, same slide, the germ layer, and then in high magnification, the intraembryonic colloq. 3.7, old placenta, and in high magnification, we had the remnants of cytotrophoblasts. And then 3.8, the same slide, which is the old placenta. And then in high magnification, here we had the fetal blood. Here, no high magnification, so we have the slide name, which is the umbilical cord, and the structure, which is the umbilical vein. That just happened again. 3.10, we have the developing heart 10 to 11 weeks. And then for 3.10 in the structure, we have the pericardium, which I haven't done that with, but there we go, the pericardium. Now we're going to go through all of the structures one by one, explain why they are like that. Okay, for the first structure, we had this alien-like shape with all of these egg follicles in the middle, all of these hundreds and hundreds of egg follicles. Now, why I suspect it is the cat ovary is because we have so many follicles within this ovary. We don't usually see this many in the human ovary, I don't think. But also because in these studies, we only really have an example of a cat ovary. Hence why I assume that it is cat. But I don't think you have to be specific. I think ovary is well enough. And then the columnar cell ring. Now, like I said, in these type of structures, we have a few things that might appear. We have the oocyte 1, which is this entire egg. So not this, but this, with the clear cytoplasm, where the granules stop, pretty much. That would be the oocyte 1. The nucleus of the oocyte 1, sometimes we can have the corona radiata, sometimes we can have zona pellucida, sometimes the antrum, but most often than not, we can always see this columnar cell ring. Doesn't really appear that columnar here, but that would be the columnar cell ring that surrounds the follicle, kind of makes up. It's the sac material of the egg sac, right? So that's the columnar cell ring. Next up is the maternal placenta, specifically old maternal placenta. Why is it old? Well, we can't really see two distinct clear layers. Also, new placenta looks very pinkish in the layer and very white in the middle. So that's why I am assuming this is the old placenta. And then the decidua basalis is just all of the pink area for the maternal placenta. Why is it maternal? Because we can see all of the cells being uneven. So there's a clump of them over here. There's not really any of them here. So again, unevenly scattered. Some are larger, some are smaller. So again, very characteristic of the maternal placenta. Also, we don't see any simple columnar amniotic epithelium border either that we see with the fetal placenta. So that would be the decidua basalis. If it was the fetal placenta instead, you would write the extraembryonic mesoderm or extraembryonic mesenchyme. In this case, we know it's the maternal, so that would be the decidua basalis. Next up here, the embryo and sagittal section. And like I said, we have a few organs we can see both in the thoracical area as well as the abdominal area. The dorsal aorta we can actually see in both. So it's non-specific to which area of the body we're looking at. Also, it appears as a large blood vessel. Again, very, very large blood vessel. If this was any clearer or any more HD quality-esque, would actually see the blood cells individually like so. But here we can't really see it. However, hopefully you still got it from the large blood vessel appearance of it. Next up is the human uterus in secretory stage. Here we don't really see the top of the uterus, kind of do. Here we can see a little bit of the top of, oh actually we don't. This is more, I think, the glands. But we can definitely see the border between the myometrium and the endometrium. Also the uterus has very characteristic glands that hopefully you can see from a very far away view, right? But usually you can see more myometrium, or the professors will show you more of the myometrium so that you can clearly see the border between them too. So endometrium from the myometrium. In this case, we were zooming in here. Now, a lot of you guys might have written down the uterine glands instead of the blood vessel. Again, if you write in spiral artery, I think it would count as well. I don't think they're that mean. But in this case, if we're looking at this specific structure, first of all, we can see a red blood cell. Again, very characteristic of red blood cells, more pinker and red toned than everything else, and very, very round. So immediately, if one of these openings has a red blood cell within them, 9 out of 10 times it's a blood vessel, right? The other thing is the walls of this structure. So here we can see these nuclei and the cytoplasm of these cells, which line. These are endothelial cells that line this blood vessel. Even though they appear as very, very thick walls, they're really not. It's just that it's very, very zoomed in, so it appears as if they have thicker walls than they actually do. This would actually be the glands, but they have very thin walls, and it might be that they're very poorly maintained, but this is definitely a blood vessel. I would have written blood vessel non-specific. I think I would have gotten full points for that, but if you wrote spiral artery, I think that would be good as well. Okay, next up, germ layer. Makes sense. Very, slim and long. The notochord is towards the bottom of the slide, only bordered by the endoderm. If this was the embryo folding, it would appear as a 3-headed clover, and the notochord would be more towards the center of the slide, with the dorsal aorta is like so, and the neural tube like so, but always underneath the neural tube, right? So that is the germ layer, and then within the germ layer we have these smaller cells. So if you see cells just floating around with nuclei that are in focus, if they ask you about one specific cell in this type of structure, again, 1000%, it's almost always the nucleated erythroblast. They're not going to ask you about a specific cell otherwise in these structures if it's not the nucleated erythroblast. Here we can see the ductus mesonephrecus. It's actually right side up this time, so this would be the somatopleura, this the splanchnopleuра. and then the intermediate mesoderm, the lateral mesoderm, and the somite. Ductus mesonephrecus, which always sits above the intermediate mesoderm. And then this would be the dorsal aorta with the lined by the endoderm, and then filled with all of these nucleated erythroblasts. If you only write erythroblasts, you're not getting any points. If you write erythroblast with nuclei, you might gain all the points. But nucleated is a lot better, in my opinion. Same slide name there, same explanation. And in this case, we only have the intraembryonic coelom. So the empty, it's not really empty, but the empty looking area within the lateral mesoderm. Here we have the old placenta. You don't have to immediately identify that it is the old placenta. Like I said, how we differ the old placenta from the new placenta by looking at the borders of the tertiary villi. So this is a tertiary villi as well. All of these are tertiary villi. So we're looking at the borders. If we don't see clear two layers acting as borders for the tertiary villi, it's not new, it's old. So in this case, we don't really see those two clear borders. We only see one vague border. Sometimes we don't really even see a border. Like here, we don't really see any cells lining, right? That's why we call this remnants of cytotrophoblasts, because sometimes they appear, sometimes they don't. There are remains of a very, very old placenta, which used to be new. Hope that makes sense. And then same thing here, old placenta, same slide, only here we're looking at fetal blood. Now, how do we differ from fetal blood and maternal blood? The fetal blood is always within a tertiary villi, or specifically within the blood vessel of a tertiary villi, and not outside in the intervillar space. There we go, intervillar space, the white area surrounding the villi. That would be the maternal area or the intervillar space. And the blood within the intervillar space is always maternal blood, while the blood within the blood vessels of the tertiary villi, within the tertiary villi, is fetal blood. You can think of these as islands, the intervillar space being the sea. So every blood within the sea belongs to the mother, and then the lakes that are within the islands, that blood belongs to the fetus. So maternal blood from fetal blood. Okay, here we have the umbilical vein. More specifically, the umbilical cord. Don't know why that disappeared. So the umbilical cord, how do we see that? First of all, we see all of these very, very, very large blood vessels surrounded by this textured area, which is known as the Wharton's jelly, and then lined by the simple columnar amniotic epithelium. We don't see any other structures. We might see the remnant of allantois like we saw in the first attempt, but here we can only see these large blood vessels, very characteristic of the umbilical cord. This would be the umbilical artery. We have two of them in the umbilical cord, and this is the umbilical vein, or vena umbilicalis would also be a very good answer to add in here. How do we know that this is the artery, this is the vein? The artery has a much smaller lumen or opening. So if we look at the furthest end here, it's this large. Well, if we look at the vein, which has a larger opening than the artery, you can see the difference, right? And then another difference is the wall. So you can see that the artery's walls kind of end here. So this would be the thickness of the arterial wall, and this is the thickness of the venous wall. Again, venal wall. The wall of the vein is a lot slimmer than the wall of the artery, but the lumen of the vein is a lot larger than the lumen of the artery. So that's why we know that this is the vein, or umbilical vein. We have, again, two arteries and only one vein. So another signifier would be that we see two of these arteries and only one that is this characteristic vein shape. Okay, last one is the developing heart, specifically 10 to 11 weeks. Why do we know that this is an older heart and not the 6 to 7 week old heart? That's because we don't see the entire heart in one under one zoomed out microscope. We only see sections of it. So the smaller heart, or the more underdeveloped heart, 6 to 7 week, we can actually see the entire heart within the scope of a microscope. However, because the 10 to 11 week old heart is a lot larger, we can only see it in sections. Another signifier that this is a heart, because we can't really see the shape, are these bow-like formations, which are all blood vessels, very, very, very large blood vessels, like the dorsal aorta. We can actually see the heart, or the actual aorta, trunk of the aorta right here, with the developing valves right there. So these bow-like formations, if we see them, we know that we're in the truncoconal region of the heart. And this specifically is the aorta, because we can see all of these valves, which really only belong to either to the aorta or between the atrium and the ventricles. There we go. Now here we were also zooming in on this area. We can see this very, very thin shape, almost like a shawl, that surrounds the entire heart here as well. And this is known as the pericardium. The pericardium surrounds the very, very the older 10 to 11 week old heart, while we can't really see this in the 6 to 7 week old heart. That's another signifier that we're at an older heart. But the biggest signifier is obviously the size of it, right? And that was it for the third attempt. Now for the fourth and final attempt, and then hopefully we can end it. The final and fourth test today, we're going to start with this slide. So take a good look. Please write down the slide name if you can. Now zooming in, we're looking at this general area. And my question will be, what is this called? We can see it here as well. So what would that be called? Okay, moving on. The next slide is the exact same. So please just repeat the slide name here unless you want to change it. And then zooming in, we're looking at this general area. And please tell me what this is called. Okay, next slide, 4.3. Whoops, this is the slide we're looking at. So please take your time to write down the slide name if you can. Okay. Now for the structure, we're zooming in to this area. And I'm going to ask you what this structure is called. Okay, next slide looks something like this. zooming in, we're seeing this area. I'm gonna ask you about this structure. So please write down the name of this structure. Okay, moving on. This is the slide you're given. Just take your time. If you know the slide name, you can write it down right now, or just give a guess. Okay, zooming in, we're seeing this structure right here. My question is, what is this structure called? Okay, next slide looks something like this. So zooming in, we're seeing this general area. Now we're going towards the right side, downwards, a little bit up actually, and we're seeing this. Finally gonna be zooming in, and we're gonna see something like this. So with that in mind, the previous slides, please tell me what this structure is called. Whoop. This entire structure, actually. In this case, I would also ask the professor to zoom out, personally. Okay. Next slide, 4.7, we're in the same area. So we're zooming out and we're going towards the upper side of the slide, upper left side. So this would be the nose right here. We're seeing it on the right now. Zoomed in, I'm gonna ask you about this specific structure. So write in slide name is the same as before, and then a new structure. Okay, next slide. Whoopsie. So that is what it looks like zoomed out in high magnification. And we're going towards the right side of this slide, so something like this. Now zooming in, thank you motorcycle, we see something like that in high magnification. My question is, what is this called? I'm gonna be circling it in. This or this, this. What are those called? If I had a microscope, I would zoom in further, but we unfortunately don't. So you only get to see them like this. Okay, gotta move on. We're in the same slide as before and the same high magnification image, right? It's like so. But now I'm asking you guys about this structure instead. So please write down the name of this structure. Slide name is the same as before. Okay. Now the final slide looks something like this. And zoomed in, we're going to see something like that. And my question here is, what is this structure called? Okay. We also have a bonus slide because we're in the final attempt. So bonus slide looks something like this. We're going to make this a little bit faster because again, it's a bonus slide and not totally a slide that I forgot or accidentally added in too many slides. And then zoomed in, it looks something like this. Like so. My question is, what is this slide called? Bonus slide. Or the structure. So slide name and structure name, please. Okay, that was your bonus slide. All right, we're gonna go through the answers real quick and then explanations, and then we can finally finish this colloquium 1 chapter. Let's go through all of the answers. 4.1, slide name was fetal placenta old. You can kind of see that it is old. I understand if you don't really see it because of the quality, but writing all of it would be perfect, or perfect score. And the structure name is the Rohrs fibrinoid. 4.2, the slide name is the same, fetal placenta old, and the structure name is the chorionic plate. 4.3, slide name developing vertebral column, and the structure name is the remnant of notochord. 4.4, the slide name is the new placenta, and the structure name is the extra embryonic mesoderm. You could also write in mesenchyme instead of mesoderm. 4.5 looks like this and is the human sperm slide, and the structure is the conglomeration of spermatozoa. 4.6, slide name embryo and sagittal section, adding in an age, and the structure name is the developing lung in pseudoglandular stage. 4.7, slide name is the same as before, and the structure in this case is the developing spinal ganglion. 4.8, the human uterus in proliferation phase, and the structure name is the smooth muscle cells. 4.9, same thing as before, human uterus in proliferation phase, only the structure name here is the arcuate artery. Blood vessels will give you, or a blood vessel would give you some points, not all. 4.10, slide name is the embryo folding, and then the structure would be the ectoderm. The bonus slide is the prostate, and the bonus structure is the prostatic gland in secretory section, but prostatic gland would hopefully give you the points as well. Now we're going to go through all of them in detail. So first of all, how do we know that this is the fetal placenta? We can see that it has a very even pink area, the extraembryonic mesenchyme or mesoderm, but it's lined by this very, very clear simple columnar amniotic epithelium border. So that's how we know we're in the fetal area. How do we know that it is old? Looking at the borders of this tertiary villi, they don't look like they have 2 layers, right? And the center of them doesn't look particularly light. So that's how we know we're in the, or it's an older specimen. Same with the blood, it's kind of dried up. You can see that it's cracking at the edges here. Very characteristic of old placenta. In high magnification, we're looking at this area right here. So in high magnification, it looks something like this. The blood is all of this pink, almost dust or mist within the intervillar space. And they might ask you about that, but in this case, they were asking you about this tissue-like area, and that is the ros fibrinoid. Let me uncover that right now so you guys can actually see. A lot of people make the mistake of assuming this is the maternal blood, or that the maternal blood is the ros fibrinoid, so be careful there. If you see something that is clearly more pink rather than red or misty, you know that you're looking at the ros fibrinoid instead. Also, there are 3 types of fibrinoid: Nitabuchs, Langhans, and Rors. Nitabuchs is directly underneath the maternal decidual basalis area. Langhans is directly underneath the chorionic plate of the fetal placenta, and then Rors is surrounding the tertiary villi, like so. Even though you are in the fetal area or placenta here, we're zooming in, we'll say, into this area, and because you see a lot of tertiary villi, all of these are ros fibrinoid, not Langhans. Next up, here, same slide as always. And then we have the chorionic plate. Why not the extraembryonic mesenchyme? That would be if we covered this area. But the chorionic plate is both the extraembryonic mesenchyme and the simple amniotic columnar amniotic epithelium, right? So both of these areas constitutes the chorionic plate. 4.3, the slide name was the developing vertebral column. Again, hopefully that makes sense. And then for the structure, all of these smaller openings that you see, all of these smaller openings that you see that kind of look like they're ripping through the bone-like material, almost like a pair of nylon socks, or the rips of a pair of nylon socks. If you can see those rips within the bones, they're usually just the remnants of notochord. 4.4, also another thing is that the remnants of notochord you can also see not only in this separate vertebral column slide, but together with the entire embryo and sagittal section cut as well. So sometimes you have the embryo and sagittal section with the vertebral column and all of the organs and the diaphragm and the ribs, right? So instead of looking at the slides vertebral column separate, they're looking at the total embryo and sagittal section, and you can see the notochord there as well, or remnant of notochord. 4.4, slide name is the new placenta. Hopefully that makes sense. Very light center, and then you can kind of see the borders very clearly, especially zooming in, you can see it. So if you feel unsure, they will zoom in, they will show it to you. You can change the slide name as well. And here we were actually looking at the inside, so the inside white part. And we can see that both in old and new placenta. It doesn't have to be new, but this would be the extraembryonic mesenchyme or the extraembryonic mesoderm. So the area within. If they asked you about this area instead, you would write the tertiary villi. But because they were only asking you about this area within, not including the borders, then we're in we're looking at the extraembryonic mesenchyme. Here we can see fetal blood compared to maternal blood. In this case, fetal blood is very unique from the maternal blood. Doesn't always have to be. The syncytial trophoblasts, the cytotrophoblasts, the blood vessels with the fetal blood. Tertiary villi is the entire thing, and then the maternal blood in the intervillar space. Like I said, if we're looking at a slide that looks very chaotic, filled with just pink splotches everywhere, some areas being more heavily dense, very, very out of focus, we're looking at the human sperm, because that's just, I would say 7 out of 10 times you just see absolutely nothing. You're very confused. And then zooming in, we still don't really see the sperm in super high detail. But we do see like clumps of sperm scattered about. And this would be known as the conglomeration of spermatozoa. We can also see the lymphocyte here as well, here and here. I don't think we can see the human urethral epithelial cell. Unless you make an argument that this is the cytoplasm and this is the nucleus of a urethral epithelial cell, but I doubt it. I would say that's more of a lymphocyte. 4.6, the embryo and sagittal section. I hope that makes sense. As soon as you see rib cages, you know that you're in that area. And because again we're in ribs, we're not looking at the end of the ribs, we're actually within the rib cage area. This is the thorax, and we only have 3-ish organs we can see in the thorax. It's either the lung, the heart, or the dorsal aorta. In this case, this has to be the lung, right? Zooming in, we see this, and that is the entire name that you have to write that out. Developing lung in pseudoglandular stage. Make sure to actually write out developing and not abbreviate it like I did. But yeah, if you only write in developing lung, you might only get half a point or a third of a point, just whatever the professor feels like giving, right? So make sure to write out the entire thing. 4.7, same slide, but here we're looking at this area, and this area is within the vertebral column. Here we can see the intervertebral disc and each vertebral column separately, right? Vertebral column, intervertebral disc, vertebral column, etc., etc. But adjacent or next to the vertebral column, we can also see these kinds of structures. It kind of looks like a plum or a kidney with a little stem sticking out, right? Very much darker compared to the rest of the vertebral column structures. And this is very characteristic of the spinal ganglion or developing spinal ganglion. We can actually see them develop here as well. They're just cut out in a weird shape. Here we can see another one, but this is almost like a perfect cross section of the developing spinal ganglion. So again, very characteristic shape, the body, and the stem of the spinal ganglion. This might also be a structure that appears in colloquium too, so make sure to remember this particular structure. 4.8, we have the human uterus in proliferation phase. So first we saw this. We can see the corner of the endometrium here. Like I said, we know that it is the uterus because we have the border between the myometrium and the endometrium. And then here that would be the end, so we can look at the top glands and see that they're very circular in shape, not really elongated. So we know we're in proliferation stage of the human uterus. But now we're actually more interested in the myometrium rather than the endometrium. And zooming in, we see something like this. Now, I believe that if they were to ask you about the smooth muscle cells, they would actually zoom in further than this and show you the individual muscle cells like they do with the immature skeletal striated muscle cells. But again, I didn't have an image for that, so hopefully this would suffice and it would just make sense in your head if they would zoom in to something like this. You could write in cells, you don't really have to write in bundle, I don't believe in this case. But in the next structure, same slide, we see this. And if we see a very, very large blood vessel within the myometrium, so we can kind of see it here, kind of here, this would be more of a radial artery perhaps. But if it's further down and it's a very large artery, I would say it's the arcuate artery. If you believe that this was the radial artery or basal artery based on this general area, it also wouldn't be completely incorrect. But in my head, it's more further down into the myometrium, and therefore I would say this would be the arcuate artery. If you wrote blood vessel, it wouldn't be completely incorrect, but you wouldn't gain all the points. 4.10, this is the slide. It looks like a 3-headed clover, right? So that would be, or a Mickey Mouse. In this case, it's actually the correct Mickey Mouse head and not an upside Mickey Mouse head because the actual slide is upside down, which you can actually see with the with the mouse. Didn't really make an effort hiding that, but in this case, try to fool you with showing you the layer, the outside layer here. And if you knew that this was an upside down slide, which isn't too hard to figure out, you would know that this would be the ectoderm, not the endoderm, which is usually at the bottom, right? So the top layer, because this is an upside down slide, it looks like the bottom layer would be the ectoderm. So right here, all of that. And then for the bonus slide, because I accidentally added an extra slide, is the prostate. And the prostate looks something like this. We also had that in the first attempt. Again, very characteristic, very uniform texture with all of the smooth muscle cells. The glands are scattered about and not in any particular shape, like with the uterus. Zooming in, we see all of the smooth cells sort of in a cross-cut section. We see the glands, which are these, and we see also the blood vessels with the blood cells within them. In our case, these are prostatic glands, and then also if you wanted to add the secretory section, you could do that as well. That was all for the Test Yourself Embryo Colloquium 1 video. I'm going to venture out and say that if you know, or if you did these videos within the span of 10 minutes for each attempt, and you got approximately a 70% on each attempt, or an average of that, I would say that you should feel fairly confident for your actual practical colloquium, unless they did a major change, right? Again, these might be structures that are very outdated, so double check it with your course first. But if you feel like you're kind of iffy, you're 50-50 with the structures, you should try to study a little bit more, and by that I would recommend the videos I went through for class 1 through 3. For the slides and structures that I didn't use, I actually added them in the final pages of this document. So you can see the areas or the structures in red are the ones I didn't use for this video, and the ones in black are the ones that I actually did. So you can see how many structures I actually didn't include, right? So it's important to study these structures as well. Also, these might not all be the exact structures that you have to know. Again, ask your professors. Maybe there are some structures that are not included here. Maybe there are some structures that are unnecessarily included here. So again, double check that with your professors. That was all for the Colloquium 1 Test Yourself videos for embryology. And now we're going to venture into Colloquium 2. So hope you guys enjoyed. Colloquium 2, going to be a lot more difficult, but let's focus on finishing Colloquium 1 first.